Talking about chapter 22 in bonding, and last time we left off with ionic bonds and ionic compounds, and we talked about during an ionic bond you have metals which make positive ions, which are called cations, and you have nonmetals which make negative ions, which are called anions, and they come together to create an ionic compound, and in that process atoms are either gaining or losing electrons, hence the ions. And we talked about how that works. So today we're going to focus on how we write the formulas for ionic compounds. Okay, so there's a few things we need to look at first before we start this. We need to know that the number of positive charges and the number of negative charges are eventually going to balance out in the ionic compound, because once the bond has taken place in an ionic compound is created, that compound itself has a neutral charge because our number of positives and our number of negatives are going to balance each other out. All right, and the formula is going to represent or show us how these charges balance each other out. And we're going to use subscripts to indicate our ratio of elements in a compound. And of course, as usual, there'll be no ones. All right, remember, the element symbol itself accounts for one atom of that element. So that's why we don't see ones in our chemical formulas for compounds. So let's talk about how this works. All right, so the first thing we have to do is when we look at the name of a compound, we have to come up with our oxidation number, or our chargers for both parts, for the metal and the nonmetal. And remember, of course, the metal is going to give us positive charge, or cation, and the nonmetals are going to give us a negative charge, or the anion. All right. Now, if you have a transition metal that is part of the compound, that transition metal, the name of the metal, is going to be followed by a Roman numeral, and that Roman numeral is the oxidation number. And we'll see how that works here in just a few minutes. Okay. And then for polyatomic ions, you'll have a list of those. You can check the list for the charges for each polyatomic ion. Remember, you cannot change the subscript in the polyatomic ion, because if you do that, then you've changed the polyatomic ion, and it might not even be a polyatomic ion anymore if you change that. So you can't change the subscripts within that polyatomic ion. Okay, and so then what you do is you'll write the symbols. So the cation always goes first, the metal goes first, and then the anion goes second, which is of course the nonmetal. And then if we're using polyatomic ions and we have to have more than one, we'll put that in parentheses. Probably doesn't make any sense right now, but you'll see how it works here in just a few minutes. And then of course we use the subscripts to show how many atoms of each element we're going to use, whether they're positive or negative charges, to make the whole thing balance out and have a neutral charge. Okay. Sometimes we'll have to use the least common multiple to balance out the charges, and again, we'll see that here in just a second. All right, so let's try a few and see how it goes. Okay, so let's look at sodium sulfide first. Okay, so if we look at sodium, of course, sodium is Na. So we have Na, sulfide. Remember, sulfide is the same thing as sulfur, just in our compounds we substitute the or change the end of the name to the "ide." So remember that "ide." So don't get confused by that. Sulfide, same thing as sulfur. Okay, so we have sulfur. So if we look on the periodic table, we see that sodium has a +1 charge. So that's a +1, and sulfur has a -2 charge. All right, so we need to balance these out. So since sulfur has a -2 charge, sodium has a +1 charge, that means we need 2 of these sodiums to balance out the sulfide. So we need 2 +1s to balance out 1 -2. So then we just do Na2S. So this little 2 right here represents 2 atoms of sodium, so that we have 2 +1s to balance out the -2. All right, let's try another one. We've got potassium. So potassium is K. Iodine is iodine, so that's I. Potassium is a +1. Iodine is a -1. This is great. They balance each other out already, so all we have to do is just write the symbols. It's just Ki. That's a really easy one. All right. Let's do the next one, barium fluoride. So barium is Ba. Fluoride, of course, is F. All right, so Ba is an alkaline earth metal, so that has a +2 charge. And let's do this because we have some room. We have a +2 charge for barium, and fluorine, of course, is a -1 charge. It's a halogen. All right, so since barium has a +2 and fluorine has a -1, that means we need 2 fluorines to balance out the +2. So we have BaF2. Okay? All right, now let's look at this one. Here we have iron oxide. Iron is a transition metal. So remember, our transition metals can have more than one charge or more than one oxidation number. So this is why we have this Roman numeral. And the Roman numeral tells us what the oxidation number is. So since it's a 3, that means iron has a +3 charge. Oxygen is in the oxygen group. It has 6 valence electrons, therefore it has a -2 charge. All right, now here's a situation where we have to use the lowest common multiple, okay? Because I can't use 2 -2s to balance out a +3. So when we look at these two numbers, 6 is going to be our lowest common multiple. So that means I have to do a times 2 here to give me 6, and I'm going to do a times 3 to give me 6. Okay, so then these numbers that we're multiplying by, these become the subscripts in our formula. So this becomes Fe2, so this 2 right here is that 2, and O3, that's this 3, is that 3 right there. Okay, that one might seem a little bit difficult, but after you do a few of these, it'll become second nature and you won't have to worry about it. All right, now here's what I would like for you to do while you're listening to this. I would like for you to pause this video and go ahead and try the next 4 on your own and see how you do. I'm going to go ahead and put the answers up. When you're done, start the video back up and check your answers, okay? So we have copper 2 chloride. So again, transition metal. That means I have copper. This copper is a +2. Chlorine is a -1. So since I've got a +2 and a -1, that means I have to have 2 chlorines to balance this out. So we have CuCl2. And this is the same substance that we used in our flame test lab. All right. Here we have sodium acetate. Acetate is a polyatomic ion, okay? So you have to look at your polyatomic ion sheet to come up with your oxidation number or your charge. Sodium, we know, is a +1. Acetate is C2H3O2, and it has a -1 charge, all right? So that works out great. Since they're both the same number, I just got to put the symbols together. So it's NaC2H3O2. Easy breezy. Okay? Zinc 2 carbonate. So here we go again. Roman numeral. This tells me that this zinc is a +2 charge. Carbonate, you got to look at your table again for the polyatomic ions. Carbonate is CO3, and it is a -2 charge. That works out great. You don't have to do anything, so it's just ZnCO3. All right, last one. Cobalt chloride. Cobalt, Roman numeral 3. That means it's a +3 charge. I'm sorry, it was cobalt iodide, not cobalt chloride. But basically the same idea. Iodide is a halogen, so it's got a -1 charge. So that means I need 3 iodides to balance this out. So I end up with COI3. Okay? So check your answers. How'd you do? Make sure you come to class with questions if you have any. And we are going to work on this several times during class. So if you're struggling a little bit, don't worry. Just make sure you let me know so I can help you. All right.